Nothing better than a good sci-fi movie with aliens in it. And aliens, they're aliens, so they got better technology than us, better spaceships. They do stuff we can't do. It appears to me that we live in a time where God of the Gaps has been supplanted by alien of the Gaps. I've had people come up to me and say, where did the pyramids come from? And I'm saying, well, I'm thinking the ancient Egyptians built it. How could they have possibly built that? That's too complicated. They must have gotten help from aliens. Alien of the Gaps.
So why isn't aliens did it a strong default explanation for hard-to-explain things? And what would make it strong? A scientific explanation is a hypothesis, meaning a concrete claim that makes specific, testable predictions about what we should observe next. The null hypothesis is the baseline, ordinary explanation that fits known laws without adding new entities. Two assumptions guide us. The same physical laws apply everywhere, and energy and momentum are conserved in all interactions. On that basis, strong explanations do two things. They reduce the number of assumptions we need, and they predict distinctive evidence that would be unlikely under ordinary causes. Occam's razor, the rule that we prefer explanations with fewer unsupported assumptions when evidence is equal, is not a slogan. It is a way to avoid hiding ignorance inside a vague agent. Saying, aliens did it, adds an unknown civilization, its motives, and its technology without making precise predictions about measurable traces. The short insight is this. Good explanations earn their keep by predicting details, not by invoking powerful actors. What do distance and energy tell us about the odds of visitors or interventions? A light year is the distance light travels in 1 year in vacuum, and even the nearest star is over 4 light years away. Travel times scale inversely with speed, but the energy cost rises steeply. At low speeds, kinetic energy scales with the square of velocity. Doubling speed needs roughly 4 times the kinetic energy. And, as you approach relativistic speeds, the required energy grows even faster. Chemical rockets reach only a tiny fraction of light speed, turning interstellar trips into multi-millennia voyages. Nuclear, or antimatter propulsion, raises energy dramatically and introduces shielding problems against interstellar dust, which at high speeds deposits destructive energy upon impact. Relativistic speeds also compress travel time for the travelers while leaving home frame time long, which reduces but does not remove the immense energy cost. Communicating with photons is vastly cheaper than moving kilograms, which is why send signals is favored over send ships by pure energy accounting. These constraints do not forbid visitors, but push their prior probability low unless evidence is both strong and specific. What kind of traces does advanced engineering reliably leave, and how do we look for them? A technosignature is any observable sign of technology, such as engineered materials, organized radio transmissions, or waste heat. Every high-power process generates waste heat because no engine is perfectly efficient. That heat must be radiated away, often in the infrared. Radio transmissions with narrow bandwidth and a drifting frequency consistent with rotation or orbital motion are unlikely to occur in nature because astrophysical sources are typically broadband or have different drift patterns. On Earth, engineered artifacts show tool marks, standardized construction sequence, and supply chains. These are observationally established by materials analysis and by matching intermediate stages across multiple sites. In space, engineered megastructures would occlude starlight in non-planetary patterns or produce infrared excess without the chemical signatures of dust. Many claimed anomalies lack these specific markers. When we measure more carefully, materials match local geology and patterns match known building techniques. The synthesis is simple. Technology is detectable through constraints it cannot avoid, especially energy use and standardized structure. Why do unexplained sightings and anomalies cluster in low-quality data? Signal-to-noise ratio is the strength of the desired signal compared to background fluctuations, and low ratios make false patterns common. A selection effect is a bias introduced when we notice or report only the surprising cases, not the full set of observations. Consumer cameras compress images, rolling shutters distort fast motion, and atmosphere refracts and blurs light. All of these mechanisms create artifacts like streaks, shape distortions, and apparent accelerations. Radar systems produce clutter from birds, temperature layers, and hardware reflections. Without careful calibration, these can mimic motion. Parallax, the apparent shift of an object against background when the observer moves, makes nearby small objects seem to jump relative to distant clouds or stars. When multiple calibrated sensors observe the same event from different locations, many anomalies resolve as satellites, aircraft, meteors, or camera effects. This is observationally established across astronomy and aviation. The insight is that ambiguity survives where instrumentation is weakest, which is exactly where extraordinary hypotheses should be held back, not advanced. How should we update our belief when a real anomaly survives the first checks? Likelihood is the probability of seeing the data we have if a given hypothesis were true. Good inference compares the likelihoods between competing hypotheses. If a pattern is expected under mundane physics and under an alien hypothesis, the observation does little to favor either. If it is far more likely under the alien hypothesis, then our credence should rise. Fast radio bursts began as puzzling millisecond radio flashes. Early on, even microwave ovens produced similar signals at observatories, which showed the need for controlled environment and precise localization. With improved measurements, many FRBs are now localized to distant galaxies and are consistent with compact object activity like magnetars, which are highly magnetized neutron stars. This is observationally supported by repetition patterns in host environments. The interstellar object, known as Oumuamua, showed unusual acceleration. Mundane explanations like outgassing are debated, but the scientific path is clear. Propose mechanisms that predict new observables, thermal emission, composition signatures, and test with future detections. Real progress happens when hypotheses stick their necks out and later observations confirm or refute them. So, why does the alien of the gaps idea persist? And what evidence would actually justify saying aliens are responsible? It persists because compressing many unknowns into a single agent feels like an explanation, and because extraterrestrial life is a plausible cosmic possibility, yet our minds discount the severe constraints of distance, energy, and measurement. Physics tells us to set a low prior for local interventions, and then be ready to raise it only with evidence that mundane processes cannot easily mimic. Decisive evidence would be multi-instrument, repeatable, and quantitatively consistent with non-terrestrial engineering. For Earth-based claims, that means artifacts with materials or isotopes not producible by known processes, tool marks inconsistent with any known manufacturing method, and a chain of intermediate features that cannot be reproduced with human means. Each of these leaves testable signatures in labs. For astronomical claims, that means persistent narrowband transmissions that drift exactly with a planet's rotation and orbit, mid-infrared waste heat spectra from systems lacking dust indicators, or transits with dynamics impossible for natural bodies but stable under engineered control. The conclusion is clear. Aliens is not a plug for gaps. It is a testable hypothesis constrained by the same laws that govern stars and stones, and it earns belief only when it predicts, and we then measure evidence that ordinary physics cannot supply. Like if this was interesting and hit the subscribe for more.